Hi. This particular time series that we have been looking at actually has a very big trend component in it, and all of these forecasting methods that I have shown so far, all the smoothing methods of simple moving average, weighted moving average, and single exponential smoothing really should not be used for this time series. And the reason is that there is such a huge apparent trend component in there that we should be using trend analysis or trend projection for forecasting it. So let's go ahead and see how trend projection and the least squares method can be used. Again, we're working with the same time series, but we have 5 past time values. The y, or the actuals, are given to us at 450, 495, 518, 563, and 584. The equations in your book, in the forecasting chapter, have the least squares method or formulas for you, and those are given with B1 and B0 as the symbols representing them, where B1 is the slope for the trend line and B sub 0 is the intercept for the trend line. Now remember, in trend analysis, always time is the independent variable. Time is the variable that we use to explain the actual. So using a table similar, or developing a table similar to what's in your book, when the authors talk about trend projection, let's go ahead and compute the t times y column. So 1 times 450 is 450, 2 times 495 is 990, etc. And the rest would be 1,554, 2,252, and 2,920. The summation of this column is 8,166. The summation of the y column is 2,610, and the summation of the t column is 15. This is the summation row. The summation row. We can also average the mean values. 15 divided by 1, 2, 3, 4, 5. Mean would be 3. So t bar equals 3. The actual for y, summation is 2610. This is the summation. 2610 divided by 5 gives us a y bar, or an average bar value of 522. The summation is what we need here. We don't need an average for it. And then we also need another column, t squared column. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. The summation for this column is 55. And we're going to need these numbers to generate the slope for the line. B sub 1 is, the formula is given to us as summation of the t times y column minus summation of the t column multiplied by summation of the y column. That term divided by n, that whole numerator divided by summation of the t squared column minus the summation of the t column squared divided by n. Using the information that we have generated here, we can fill in the blanks. So B1 will be summation of t times y column. Here's the t times y column. Here's the summation for it. So that'll be 8166 minus the summation of the T column, which is 15, multiplied by summation of the Y column, which is 2610. That whole term must be divided by n, and n is 1, 2, 3, 4, 5. We have 5 observations divided by 5. That's our numerator, and we divide that by summation of the T squared column. Here's the T squared column right there, and the summation for it is 55. So we put 55 minus the summation of the T column squared. So here's the T column. 15 is its summation. 15 squared is what we're looking for. So 15 squared. So 15 squared divided by n. N is 5. So if you go through the math here, the numerator will end up being 8166 minus 39,150 divided by 5. And the denominator is 55 minus 225 divided by 5. And of course, order of operations is important. So now that we have that, we can go on to a new page because I'm running out of room. And my B1 then can be computed using this, and that will be 8166 minus 7,830 divided by 55 minus 45. So my B1 would be 336 divided by 10, which will give me 33.6. That's my B1, that's my slope for the line. I need to use that number and my T bar and my Y bar in order to compute the point of intercept. The point of intercept, B sub 0, is equal to Y hat, I'm sorry, not Y hat, Y bar, the average Y value, minus the slope times the average time T value. So Y bar is 522 minus slope, which I computed to be 33.6, multiplied by average T value, which is 3, and I end up with 421.2. So my equation for the line is, and this is a trend equation, the trend for any given time period is equal to intercept plus slope times whatever time period I want to compute it for. So if I have 5 time periods, I averaged all the findings from that to come up with this trend equation. And if I want to use that trend equation to compute the trend forecast for time period 6, then I would do 421.2 plus 33.6 times 6. And that number would be 622.8. Then, and you can see that for every time that we go into the future, we're estimating about 33.6 increase in sales, if these are sales. So the trend forecast meaning a forecast that accounts for trend, for time period 7 then, would be 421.2 plus 33.6 times 7. And that number would be 656.4. And another way of getting this could have been that I could have added 622.8 and 33.6 together to get this new number. And essentially I'm saying for every time that goes by, I can expect an average increase of 33.6. And I say average increase of 33.6 because, of course, the sign is positive. If this difference right here were negative, and we would end up with a negative number here, then the slope for our line would be downward, going down. But in this case, the slope for our line is upward. And that's the trend projection or the trend analysis component that I wanted to talk about. In fact, if you do go through the math, and once you want to compute error analysis for this time series, then you can go back and use our forecasting model, which now our forecasting model is essentially this right here. This is our forecasting model. Now you can use that forecasting model and plug in here 1 or 2 or 3 or 4 or 5 in here, come up with the forecast for time period 1, 2, 3, 4, 5, list those numbers in this column, and that will be your forecast. So our forecast for time period 1 will be 421.2 plus 33.6 times 1. And that number will be, let me give that number to you, will be 454.8. 454.8. Now you have an actual for time period 1, you have a forecast for time period 1, and you can do error analysis. Forecast for time period 2 is 421.2 plus 33.6 times 2, and that number will be 488.4. And you can continue on, fill in the blank, calculate forecasts using this trend projection method. You know what your actuals were. If you were to use a trend model, these would be what your forecasts would have been, and then you can compare these numbers and do error analysis and calculate mean squared error, mean absolute deviation, mean absolute percent error, and so on, tracking signal, and all that. Thank you for your attention. This was Dr. Jana Shafai, Dr. J, and I hope you learned from this lesson. Thank you.